Hey, 8th graders, if you are watching this video, you guys have completed part 1 of your chapter 2 enrichment assignment in order to retake the force and motion chapter 2 quiz. So this is a requirement that you guys not only complete part 1, but that you guys watch this video as well, as I'm going to go over some of the mistakes I saw in the quiz using the materials in this assignment. Okay, so again, if you're retaking the chapter 2 quiz, you need to complete part 1. Okay, so for this, you guys should have opened up the sim link and looked at this example object, which had a mass of 1 kilogram. So this is our 1 kilogram object here. Okay, it is at rest for its initial velocity, and we are going to apply a force 20 newtons to the left. So I'm going to go ahead and hit run and then prepare a force, and I'm going to prepare a force that is 20 newtons to the left. So that's 2 clicks. 1 click is 10 newtons. Okay, and then I'm going to see what happens to this object. So I'm going to go ahead and press exert force and notice that my object starts moving to the left. If I click analyze, okay, and look at my little graph here, my change in velocity was 2 centimeters per second, okay, to the left. Okay, so on this, I'm going to go ahead and mark in here and say this started moving, okay, and my change in velocity was 2 centimeters per second. Okay, you guys are going to do the exact same thing, or you should have already done the exact same thing on this next part where you guys are going to look at a couple more different motions. Okay, so on this one, we had 4 different pucks all moving at different speeds. So if I go ahead and reset this build, and look, I want 4 pucks, all of which are 1 kilogram in mass. So I'm going to go ahead and grab my 4 pucks in my sim. So here's A, B, C, and D, and I'm going to set their speeds all at varying speeds. So puck A is going to go 2 centimeters to the right, so I'm going to click on it, 2 centimeters to the right. Okay, this one is 4 centimeters to the right, so I'm going to go ahead and click on this one and go 4 centimeters to the right. Okay, this one is going to be moving to the left 1 centimeter per second. So left 1 centimeter per second. Okay, and this last one is going to be moving to the right 1 centimeter per second. Okay, so once I have all those velocities, I'm going to hit run and prepare force. Notice how they all move differently. Okay, and then I'm going to give each the exact same force. Okay, so 20 newtons of force to the left. So A has 20 to the left, B 20 to the left, C 20 to the left, and D 20 to the left. And I'm going to exert my force and watch what happens on all of these. Okay, so if I look at them, okay, let me move my little face here. I've got a change in 2 centimeters per second to the left on this. So this first one stopped moving, so I'm going to write in here that it stopped moving. This one went from 4 to 2, so it slowed down. Okay, this one was going 1 centimeter to the left and then sped up and is now going 3 centimeters per second to the left, so this one sped up. And then finally, this last puck D, was going 1 centimeter per second to the right. And it looks like it went from 1 to -1, so it changed directions. Okay, so I would put on here, change directions. Okay. For all of these, they all had the exact same change in velocity of 2 centimeters per second. So I'm going to put 2 in this last group. Okay, on the next slides, we've got these questions. Which puck had the biggest change in velocity? The reason I'm asking this question is because I saw a big misconception on the test. Okay, if I look back at this data table, okay, they all have a change in velocity of 2. And then if I look at the original example I did, it also had a change in velocity of 2. This object started moving. Okay, this object stopped moving, this object slowed down, this object sped up, and this object changed direction. One of the answers I saw a lot of on the test when asked kind of which had the biggest change in velocity or which experienced more force, was that objects that are changing their motion, either speeding up, slowing down, whatever the case, that it takes different force to do that. But what we saw is they all changed velocity by 2 centimeters per second. Okay, so it doesn't matter if an object is speeding up, slowing down, starting, stopping, or changing direction. If it changes by 2 centimeters per second, okay, then all are experiencing the same change in velocity. So I should have circled this last question right here. Okay, the next question asked us, which puck experienced the greatest force? Again, because they are all changing velocity by the exact same amount, Okay, it means they all have the same force. I saw a lot of kids respond saying, hey, this one, stop moving, and it takes more force to stop something moving than it does to speed something up. Okay, it doesn't matter if it has the same change of velocity, it's experiencing the same force. So for this one that asked which puck experienced the greatest force, okay, you guys should have circled this last one here, all experience the same force. Okay, second part of part 1, you guys, same sim link. You guys are going to do 3 different pucks though. One is going to be a different size. So we're going to have puck A is going to be a 1 kilogram puck, okay, which is already set out there. And then puck B and puck C are both going to be 2 kilogram pucks. The reason I'm doing this problem is kind of to emulate the bocce ball one that you guys got to see in the quiz. Okay, so where we had the gray bocce ball had a smaller mass than both the pink and the blue. Okay, so I kind of wanted to ask you guys some of these exact same questions. So there's our 3 pucks, 1 kilogram, puck B is 2 kilograms, puck C is 2 kilograms as well, so B and C are equal mass. Okay, and then I'm going to go ahead and set their velocities. Okay, puck 1 was 1 centimeter per second to the right, so we're going 1 centimeter per second to the right. Okay, puck 2 is 0, so it's at rest. Okay, and then puck 3 is 2 centimeters per second to the right. So what I'm going to do on this part is go ahead and I'm going to prepare my force. So I'm going to hit run, prepare force, and then it asks me to set the force provided on the table on the next slide. Okay, so if I take a look at this, puck 1 is only going to experience a force of 10 newtons to the right. So that's going to be 1 click. So puck A, it's 1 click to the right. Whoops, there we go. And puck B is going to be 2 clicks to the right. So here's puck B, 2 clicks to the right, and then puck C is going to experience a force of 20 newtons to the right as well. Okay, so here's puck C, here's our 20 newtons to the right. Okay, and I'm going to go ahead and prepare force. Okay, so if we take a look at our analyze, okay, they all have a change of 1 centimeter per second. So puck A started out going 1, it sped up to go 2. Okay. Puck B started out at rest and sped up to go 1. It had a change of 1. Object C was at 2. It sped up to 3. It also had a change of 1. Okay, notice that we did not put the same force on those objects. So here were the forces I used. For this one, I would have recorded that puck 1. Let's see, our puck 1 sped up. Puck 2 started moving. And puck C sped up as well. Okay, so we would look at this and say change in velocity. All of them had a change in velocity of 1. Okay, so that leads us to our next questions. Oops, excuse me, 1. Okay, which puck or pucks had the greatest change in velocity? Okay, so first of all, if we ask the question that you guys saw in the quiz, which ball was most massive, you guys should have said the pink and the blue because they were both 1.1 kilograms. Versus the gray one was just 0.9. So with this one, which puck or pucks had the biggest change in velocity? If we look back at that data table that we just filled out, okay, they all had a change in velocity of 1. Therefore, it doesn't matter if they were speeding up, starting and stopping, or slowing down, they all had the same change in velocity. Okay, so there's our velocity change of 1. So on slide 10, you should have answered that all experienced the same change in velocity. With that being said, which puck or pucks experienced the largest force exertion? So if we look back, okay, they all had the exact same change, but did we put the same force on them? So if we scroll back to when we put our force, we can see this one only had a force of 10, this one had a force of 20, and C had a force of 20 as well. Okay, so did they all have the same force? No. Which ones had the most? Puck B and puck C. Okay. So you guys should have circled B and C there. And then you can explain why. So make sure you guys consider mass in that. Think of the heavy shopping cart versus the light shopping cart. If you want them to both go the same speed, okay, which one do you have to push harder to do and why? Okay, if you guys think back, you can also kind of tie in the word inertia and that should help you out there. Okay, basically you guys should notice that, if we have a higher mass, it's going to take a little bit more force to push. So why did B and C have more force needed? Well, they have a heavier mass, therefore they have inertia, and they want to continue doing what they're doing. So to change their speed, whether it's speeding up, slowing down, starting, stopping, or changing directions, okay, if they all change velocity by the same amount, they all experienced different forces if they have different masses. If they're all the same mass, they're going to experience the same force. Okay, if you guys have any questions, please let me know. In order to retake, you guys will need to come kind of prove to me that you watched this. And the secret password is going to be raccoon. Okay, or raccoon. Wow, I just said that really weird. So if you guys have watched this, come show me, tell me your secret password, and then I'll look through your assignment, let you guys know if you have any questions, and then you will be able to retake if you need. Hope you guys are having a great day.